Hello, welcome to my new video. This time I want to talk about the Meraki Troubleshooting built-in tools for Wi-Fi. So if you are new to Meraki, this is going to be a useful video for you. Or if you are exploring Meraki to maybe replace an existing solution in your organization, this is going to be useful to you. If you have a Meraki network, I'm sure that maybe at one point you came over this, but we're going to go over the different settings and how to use them to help you monitor and troubleshoot your Wi-Fi network. So the first thing that I would like you to do is if you go to wireless RF spectrum, once you are here, it is going to show you all the access points in your network, and it's going to give you an average channel utilization depending on the access point. For instance, on this test access point, we have the 2.4 gigahertz band enabled, so as the 5 gigahertz band. And for the 2.4 gigahertz band, we're using channel 11. And for the 5 gigahertz, we're using channel 100. And if you can see, if these are dual band access points, you'll see the channels that specific band is using and an average utilization. As you can see here, this is something common in most Wi-Fi deployments, and that is that the 2.4 gigahertz band is busier or saturated compared to the 5 gigahertz band, and that is because we have more devices and less channels available, right? So just keep in mind that as you are looking at the spectrum information, that's going to be based on specific access points, right? So let's click on this first access point. And when you click on it, it's going to again show you the channels that the access point is working on, but the spectrum information that's being recorded is for the entire band, not just for these two channels that the access point is being broadcasting. So on the 2.4 gigahertz band, we're going to give this a couple of minutes to populate and collect information. But you're going to have the different channels down here. The corresponding frequency is going to be down here. And then you're going to have some type of waterfall view, right? That is going to measure and record about 3 minutes worth of captured information for you to look at. Because what's happening here is live information. As you could see, this changes with every second or minute. But this is the information that is being recorded for up to 3 minutes, so you can use it as a reference point. And then down here, you're going to have the utilization information for the channels that this access point is measuring, right? So you're going to have the channels on the 2.4 gigahertz band, and then if I click on the 5 gigahertz band, you're going to have the channels for the 5 gigahertz band. Something to keep in mind down here though is that you're going to have this number varies, as you could see, 53, 50, like it depends on the utilization at that specific time that you are seeing. But it could be that this utilization changes, right, for whatever reason. So you have to keep an eye on that. The fact that you see, in this case, we're seeing 53% utilization on channel 11 does not mean that it's going to stay like that for the whole day. It could not. So it's up to you to decide that, to monitor the network and learn that. So also another thing to keep in mind is that when you see something like this, that let's use this number as an example, 53% channel utilization, it means that you only have 47% of availability, right, on that channel, meaning that if you have any devices communicating on channel 11, 53% of that channel is clogged, right, with noise, cannot be used to transmit data. So even if you have a strong signal, let's say that you have a client device connected to your access point on channel 11, and it has a strong signal from the client device to the access point, the throughput is going to be low because you only have 47% of bandwidth available to be shared by all devices around you. So that's something to keep in mind. If you click on interfering APs, that's going to show you the access points that are interfering or sending a lot of noise around, in this case, around this other access point that is displaying that information, right? So when you see that the signal strength is a low number, you know, if you have something in the 20s, well, if you have 20, there's something literally right next to it in the 30s, 40s, 50s, the lower the number, the closer these other access points or radios are to these access points that is doing the spectrum analysis. So that's kind of gonna give you an idea of you know the location, the physical location of the access point, you know, how far it is from the other. As you could see, if I went over to another page, right, that, you know, it's gonna record more of this. Let's do page page 8. It's gonna these access points doing the spectrum analysis, it's gonna see a signal coming from other access points, but because they're farther away, the signal level is less, so it's gonna cause less interference, but interference nonetheless. So as you can imagine, sometimes, or you don't have any control of this because these are just Wi-Fi signals traveling over the spectrum. You know, you may not have a way to stop them from coming in your vicinities, but most of the time you're going to be dealing with this with what is around you. Okay, so something else to keep in mind is that this information that you see here, we're going to click on the 5 gigahertz in a minute, but let's just talk about the concept, because it is the same for the 2.4 and 5 gigahertz. This information that you see here is the information that this specific access point is seeing at that specific time. Meaning this, you have to provide context to this data, right? The fact that you are seeing this, I mean, you have to understand the data and apply it to your specific environment. Let me give you an example. When we work in warehouses and distribution centers, right? These are large places, and sometimes the access points are mounted 20, 25 feet above ground level. That would be the interference the access point is seeing around itself, right? If you are on the floor, right, 25 feet under the access point, the client device may be experiencing interference levels from other sources, right? So you have to keep that in mind when troubleshooting and using this information to help you troubleshoot. Now, the truth is, whether you have interference that is being detected at the access point level or interference that is being detected at the client level, it doesn't really matter. It's interference, and it's going to affect the signal and communication. But you have to use this information to help you troubleshoot the problem, right? You would like to find the sources of interference in your network. The other thing that I wanted to talk to you about is this. Let's go back to utilization. As you could see, we have the channel utilization that this access point sees on the 2.4 gigahertz band. But it doesn't really mean that all the utilization you see here is coming from interfering access points, right? Because you have to remember this. Spectrum analysis is analyzing the spectrum, and the wireless spectrum is being utilized by other devices as well, not only Wi-Fi devices. Or you could have interference coming from non-Wi-Fi devices, such as electrical outlets, electrical lights, light bulbs, machinery, so on and so forth. So if you were to, let's say you're saying, oh my God, I have like 54% channel utilization on channel 11, what access points do I have to, or antennas do I have to turn off so I decrease the utilization? Well, maybe the noise is coming from non-Wi-Fi devices and you don't have any control over that, right? So just keep that in mind. So if we go to the 5 gigahertz band, it's going to be the same concept. You're going to see this populating over all the channels. So while this is happening, I want to show you this. In this case, I am using Meraki Channelizer, which is one of the spectrum analyzers that you could use in the market. There are many more out there. And the information that you see here on Channelizer may not necessarily be the exact information that you're going to see here at the access point level. The reason for that is because the algorithms that, in this case, Meraki uses to measure the amount of signal that is considered interference, it is different from the algorithms that, in this case, Channelizers uses to measure signal that is considered interference. But don't get caught up into why one shows more interference than the other. The truth is that if you see interference, it's bad, right? So even if the interference level is of a couple of decibels or maybe 10, 15 decibels, if you have 35% interference compared to another application that measures 45% interference, it doesn't really matter, it's bad. So just keep that in mind. We prefer relying on the data from the spectrum analyzer more than the data that we get from the spectrum analyzers on the access point. The reason for that is because we are seeing what the client sees and experiences, because we're usually next to the client, right? And by client, I mean the client device. And as you can see here, is somewhat similar. Like in this case, where you're seeing high levels of interference on channel 11, and that's something that you see here, right? Like it says that utilization is about 52%, and if we came down here, the utilization on channel 11 may be about 20 or 30%. So it doesn't matter. You could use this as a reference point, because remember, this is what the access point is seeing compared to what we're capturing at the ground level next to the client devices. The same thing with the 5 gigahertz bands down here. You could see the channels, the utilization. And another reason why we like using the Channelizer is because it has built-in signatures. So if there's like a problem, we can use one of these built-in signatures to kind of identify what's causing the problem, something that you don't have here at the access point level. And lastly, something that this is going to be super useful for you to keep it in mind. Even though the information from the spectrum analyzer may be different, a little bit different from the information that the access point sees. If you have automatic channel selection on your access points, right? This is the information that that algorithm is going to rely on to adjust the channels that is being broadcasting and transmitting on. To be honest with you, I haven't read a paper where Meraki discloses in details the information that it uses to make that selection, or what threshold it is before it switches channels, but it is based on what the access point senses at any given time. So if we're using automatic channel selection, that this is one of the factors that is going to influence the access point from switching channels. Is going to be based on the utilization, right? So that's something to keep in mind. Again, we still prefer using a real spectrum analyzer, because with this we can go deeper into the configuration, right? We can go deeper and zooming into the frequencies, and we can also attach a patch antenna and find the source of interference. So, but again, going back to your point, if you don't have, like a spectrum analyzer on premise, you can definitely use what Meraki and Cisco, because this is the same available in Cisco and even the other enterprise graded Wi-Fi vendors, they do have a version of this. But if you have Meraki, this is part of the system. You don't have to pay for any extra license to utilize this, and it's good information. So I hope this is useful to you, and I hope this helps you troubleshoot the Wi-Fi problems. If you ever need an expert wireless eye to come over on site and assist you troubleshooting, analyzing, or deploying a Wi-Fi solution, we'll be more than happy to assist you. Our company is JD Tech Solutions out of New Jersey, www.jdtechsolutions.net. Have a great day. I'll talk to you later.